All right, in this video, we're going to talk through Chapter 7 of Baronet's Logic. This is the chapter on propositional logic, and I'm going to talk through probably the first couple of sections A and B of our book. So to begin with, let me try to explain the difference between categorical logic, which is what you've been studying in Chapter 6, and propositional logic, which is what we're starting today. Categorical logic takes for its basic building blocks class terms. That is, terms that name a class of items. So for example, we were talking about all S are P, right? All dogs are mammals. Your basic building block was the S and the P, the subject and the predicate, dogs and mammals. Now, here's the thing about categorical logic. Dogs and mammals, those are just classes of items. Those are not complete statements. Now, categorical logic is fine. It can do a lot of work for us as far as it goes. However, it's got some real limitations. There are a lot of kinds of natural language statements that you're not going to be able to capture with categorical logic. Propositional logic is far more powerful, and we can do a lot more with it. So the big difference between categorical logic and propositional logic is that propositional logic takes for its basic building blocks not a single term like dogs or mammals, but a complete statement, something that could be stated in a sentence. There would be a complete sentence. So instead of the basic building block being dogs, the basic fundamental building block is going to be a simple statement, such as the dog ran, or dogs smell bad, or whatever you want. But it's going to be a complete sentence, as it were. That is a proposition. That's why it's propositional logic, because the basic building blocks are propositions. Propositions are statements that are either true or false. Now, dog, which is the basic building block, a class term in categorical logic, dog isn't true or false. You have to say something about dogs to make it true or false to give it a truth value. But the basic building blocks of propositional logic are these propositions, which are true or false. So the way that propositional logic works is we give precise definitions to a certain set of terms, namely these logical connectives, which include the words and synonyms, or, not, if, and only if, and synonymous terms. We're going to give these very precise logical truth conditions, and that's going to allow us to do a lot of stuff. So let's look for a second at these logical operators. Now, what we're going to do, we're going to use logical operators, and logical operators are the symbols that we use to symbolize these connectives, and, or, not, if, or only if. So we've got the logical connectives, and then we've got the simple statements that they connect. And simple statements can be contrasted with compound statements, all right? What's the difference between a simple statement and a compound statement? Well, a simple statement will not contain any other statements, and it won't contain any logical operators as a component. A compound statement is when a logical operator joins together two or more simple statements. So for example, if I say Hamlet is a tragedy, that's simple. There are no component parts in there which are themselves propositions. And there are none of our logical connectives. There's no and, or, not, if, or only if. Compare that though with the compound statement. Hamlet is a tragedy and Kung Fu Panda is a comedy. Now that is a compound statement because it contains two other simple statements, and those two simple statements are joined by the logical connective and. So a compound statement is going to have at least one simple statement, and it's going to have a logical operator as a component. Okay. Let's look at the logical operators. So the first, we've got 5. The first operator we want to look at is this sideways squiggle or sideways S that's called the tilde. And that operator symbolizes or expresses, is used to translate the word not. It captures the idea of negation. Now, it can also translate synonymous expressions like it is not the case that. Tilde can also translate that. The next one is the dot, and that is a conjunction sign. And the dot can translate the word and, or synonymous words like also, moreover, even but. Now, but might not sound like it means the same thing to you as and. In English, you would use those in different contexts and in different ways. However, they have the same logical force, even though they may have different linguistic connotations. Third is this little V. It's actually called the wedge, and it's the disjunction sign. Now, a conjunction is when you join two things together. A disjunction translates or either this is true or that is true. Also, it can translate the word unless. Now, unless may not sound like it's a synonym of or. It may sound like, whoa, those are really different words. But logically, actually, they have the same force. So I could say this. You can have cherry pie or you can have chocolate pie. I could say the same thing by saying, you can have cherry pie, or I'm sorry, I'd say this. I'd say, I will have cherry pie unless I have chocolate pie. Now, I'm saying the same thing. I'm going to have one or the other. So unless logically has the same force as or. Fourth is this horseshoe. Sometimes in some of my examples, I might write it as an arrow, but the arrow is going to be pointing to the right. The horseshoe symbolizes the conditional relationship between two simple statements. It can translate the words if, then. It can also translate the word only if. I'm going to say a lot more about that because that can be confusing. So hold on, and I'll say more about that later. Now, one thing to note about the horseshoe is it always points in that one direction. You can't point it back the other direction. Fifth is this triple bar, and the triple bar represents a biconditional relationship. It translates the expression if and only if. Again, I'll say more about that in a bit. So let me give you an example. When you want to translate an English sentence, a natural language sentence, into the symbolism of propositional logic, here's what you're going to do. You are going to take each of the simple statements in a compound statement, and you are going to assign to it arbitrarily a capital letter. And then you're going to take the logical connectives in that statement, and you're going to represent those with one of the appropriate operators. So if we have this sentence, Hamlet is a tragedy and Kung Fu Panda is a comedy, we're going to stipulate, okay, Hamlet is a tragedy. That's a simple statement, and I'm going to represent that with an H. And Kung Fu Panda is a comedy. That's another simple statement, and I'm just going to stipulate, I'm going to represent that with a K. And the only other word that's left there is the logical connective, the and that gets a dot. So we can represent that entire compound statement by saying H dot K. That gives us the simple statements and their logical relationships to one another. We're going to do a lot more practice of how to translate sentences into this symbolism. Let me say a little bit more about each of the logical operators then. First of all, negation. Statements in which not, and it is not the case that, are used to deny the statement that follows them. So if you have today is Monday, that's a simple statement. Let's make that M. If you want to say today is not Monday, That would be tilde M. Tilde M says, it is not the case that today is Monday. That's what that says. The tilde always immediately precedes on the left-hand side the statement that it negates. The tilde immediately precedes the statement that it negates. So you got that tilde M. So another example, if I were to say gold is selling at $1,000 an ounce, we'll just stipulate that statement is G. Now, if you want to say it's not the case that gold is selling at $1,000 an ounce, it is not the case that gets represented by the tilde. So you've got tilde G. Conjunction, a compound statement with two statements connected by the dot symbol is a conjunction. So the dot can translate words like, as we said, and, but, even still, moreover, etc., etc. So if I want to say honesty is the best policy and lying is for scoundrels, that compound statement contains two simple statements. And I'll just stipulate that H represents honesty is the best policy. And I'll stipulate that L represents lying is for scoundrels. And of course, the and is the conjunction, and it gets represented with a dot. So I can represent that whole thing with H dot L. Now, you could, let's say that compound statement, instead of and, it had moreover. Again, you still got these two simple statements, and they're conjoined. And so you would still represent that with H dot L. Now take a look at this last example here. Frank and Ernest teach music. Now this one might confuse you because you see the and, right? And you're thinking, well, that's a conjunction sign, so it must be conjoining two simple statements. But it looks like there's only one simple statement. Ernest teach music, and that conjoins Frank, but Frank isn't a simple statement, right? So what's going on here? Are there two simple statements to conjoin or not? And the answer is yes, there are two simple statements, but they're not explicitly spelled out. As an English language speaker, you should be able to know that what this means. When we say Frank and Ernest teach music, what we mean is Frank teaches music, simple statement number one, and Ernest teaches music, simple statement number two. So we'll just stipulate F stands for Frank teaches music, and E stands for Ernest teaches music. And then we would symbolize Frank and Ernest teach music by saying F dot E. So that one's got a little nuance in it. Next, disjunction. A disjunction is a compound statement with two statements, and these are called disjuncts, each of the simple statements, two statements connected by a wedge symbol. And the wedge again translates or, unless, otherwise, or either or. So for example, let's say we had Paris is the city of lights, or Big Ben is in London. We would stipulate P represents that first simple statement, B represents the second one, and we've got P wedge B. What about this one? She is either a Pisces or a Scorpio. Again, this is kind of like the Frank and Ernest example. You might look at that or and say, well, I know that one of the disjuncts looks like she is a Pisces, but what's the other disjunct? It can't just be a Scorpio, because a Scorpio is not a statement. It's just a class term. It doesn't have a truth value. So what's going on? Well, implicitly, here's what it's saying. She is a Pisces or she is a Scorpio. So we'll just stipulate P stands for she's a Pisces, S stands for she's a Scorpio, and we represent the statement as P wedge S. Or look at this third one. Here we've got the word unless. And this time it doesn't come between two simple statements. It comes like before two of them. We've got, unless it rains today, we will go swimming. So what are the two simple statements? Well, the first one is it's going to rain today. The second one is we will go swimming. But the unless comes before both of them. you have to have your knowledge of just how the English language works. It's going to have to function for you contextually. We would still represent this as R wedge F, saying either it's going to rain today or we're going to go swimming. Again, when you symbolize these compound statements, what you're capturing is not, you're eliminating all of the nuances of the English language, all the things that make poetry nice. But what you're boiling it down to is the pure, pristine, logical essence or structure of that statement. And you're allowing us to see like the bare bones, the anatomy of what's essentially there, the logical relations between the component parts. Doesn't make good poetry, but it makes for clarity in this context, logically. Okay, conditional statements. So conditional statements have an antecedent and a consequent as components. The antecedent is going to be a simple statement, and the consequent is going to be a simple statement. Now, what do I mean by the antecedent and the consequent? The antecedent is the simple statement that immediately follows the word if. The consequent is the simple statement that immediately follows the word then. All right. So that's, and in between those two, when you symbolize it, is going to be the horseshoe, the conditional sign. So let's say we've got this statement. If you wash the car, then you can go to the movies. Now, you wash the car is the first simple statement, and it immediately follows the if. It's the antecedent. You can go to the movies is the second simple statement, and it immediately follows then. And so it's the consequent. Now, when you symbolize that, you put the antecedent on the left-hand side, the open-ended side of the horseshoe, and you put the consequent on the right-hand side, the closed end of the horseshoe. And what's that saying is, if this first simple statement is true, then the second one is true. Another way of saying this is that the antecedent gives you a sufficient condition for the occurrence or the truth of the consequent. The consequent gives you a necessary condition, but not a sufficient condition for the truth of the antecedent. I'll revisit that concept later. So let's say we had an English sentence that kind of put it in a slightly different order. You can go to the movies if you wash the car. Now, in this case, there's no then. The word then doesn't occur. And the if happens in the middle of the word, in the middle of the sentence. So what's up with this? Well, logically, it doesn't change anything. The simple statement that immediately follows the if is you wash the car, the same one. And the other statement, even though it comes first, it's still the consequent. It's what's true if the antecedent is true. So we symbolize this exactly the same way as the top sentence. If W, then M. Now, what about only if? And this is the one that gets kind of tricky. I said before that the antecedent of a conditional statement is sufficient, but not necessary for the consequent. And the reverse is true about the consequent. The consequent is necessary, but not sufficient for the truth of the antecedent. That's important to keep in mind for translating the only if. Only if, the simple statement that follows the expression only if is giving you a necessary condition. It's not giving you a sufficient condition. That means the statement that follows only if is the consequent of a conditional, not the antecedent. The statement that follows an if is giving you a sufficient condition. It's the antecedent. The statement that follows only if is giving you a necessary condition. It's the consequent. So look at this. If you live in New Jersey, then you live in the US. That's if in, then you. But what if you have, that's the standard version. Now, what if you have, you live in New Jersey, only if you live in the US. The only if is different. Only if is giving you, the statement that follows the only if is the consequence. So you're going to represent this like this: if and then you, because this simple statement, the only if statement, is the consequence. And that's true even if the only if statement comes first in the English language sentence. So if you have only if you live in the US, will you live in New Jersey? Well, you live in the US is the only if statement. It's the consequence because it follows an only if. So the you, that statement is going to be represented as the consequence. That you live in New Jersey, the end statement is still going to come first, even though it comes last in the English sentence. I've got a whole other video which walks through this a little bit more slowly if you need to hear this again, which I don't blame you if you do. But the point is that word order is not the decisive factor. Or like the order in a sentence is not really what ultimately matters for symbolization. It's the logical relationships between those component simple statements, which we're trying to get at. And those logical relationships can be expressed in different kinds of sentences, which can even put the statements in different order. What matters is what logical connectives are there and how they are relating those simple statements together. This brings us, and I'm almost done, to the biconditional. Now, a biconditional is a triple bar, and it translates the statement if and only if. Now remember, if means something different from only if. But when you have them both together, well, then what you're saying is each statement, each term is necessary and sufficient for the other one to occur, both. It's like saying, so check this out. If you eat your spinach, then you get ice cream. That's if S, then I. But it's also like saying you get your ice cream only if you eat your spinach. In other words, if I, then S. Both are true. If you want to say if S, then I, and if I, then S, then you're saying I, if and only if S. It's like there's arrows pointing in both directions. If either one of those is true, then the other one must be true. That's what the biconditional is saying. Okay, let's do an example here real quick. Let's say we get this sentence: I'll stop by to visit only if I have finished my homework. All right, you can see the two simple statements. I'll stop by to visit. You can pick a letter to represent that. Call it P, or call it V for visit, I guess. I have finished my homework is another simple statement. We'll call that F for finished. It doesn't matter. Now, what's the logical connective? Only if. All right. Now, what kind of statement follows the only if? That's right. It's the consequence of a conditional that follows the only if. That means we're going to have if V, then F. Because the F follows the only if. It's the consequent. They symbolized it with H. It doesn't matter, but that's what they came up with. All right, that's it for today. That's it for 7A and B. We will do more later.